Okay, so what we're going to be covering in this second section about plotting is ggplot2. Okay, and so we learned earlier today about the capabilities that R has. We started to play around with base plot and all the different options you have with base plot, and hopefully you can see that you can easily customize and make a wide variety of plots, and then export them, and it's all relatively straightforward, and it doesn't take too much work to make a plot that looks really, really good. That said, things could be even easier, and we got to grips with how baseplot uses this pen and paper model, where once you write something, that's it, and you can't dynamically update your plot as you do as you go. So to kind of extend the capability, your plotting capabilities now, we're going to talk about ggplot. I don't know why I keep saying ggplot. Ggplot. Okay. So ggplot uses methods that are similar to things like lattice plot as well, which we will not be covering. But lattice is, if you get really into data visualization, lattice is another option you can look into. And so it was created by this gentleman called Hadley Wickham. And it's the idea he wanted to create something that's very intuitive for plotting, that enables you to make things very quickly and reproducibly, to get to something that's publication quality. And he builds on this idea of a concept of a grammar of graphics, which means you use a kind of a consistent syntax at the center, but then you can use that to construct a wide range of complex graphics from this consistent vocabulary at the beginning. Okay, and so this is maybe where it differs from somewhere like baseplot, if you remember, because we had several different functions for doing several different things. And although we have the same data frame going in, some of the names changed with how you would add stuff like labels and things like that. And so it can get a little confusing about what you're doing for which function. So ggplot tries to simplify that. And so ggplot is part of this a group of packages called the tidyverse. And so they are a group of packages and a community that are designed to make anything related to data science much, much easier and much more functional in R. And so that's what we're going to talk a little bit about tomorrow morning. And some of the packages really, really can take your R coding to the next level, just simplifying a lot of things that would typically, you could spend half an hour trying to figure out to do something, and then there's a function that will take care of it in 2 minutes in tidyverse. And these are common operations that you're going to be wanting to do. And so there's a link here to that training, but we're going to cover that tomorrow. So why should we use ggplot? Actually, something else I'll mention as well about tidyverse and Hadley Wickham. He is now chief scientist at RStudio. So tidyverse is getting, it's big, it's getting bigger, and it's co-integrated with the RStudio ecosystem as well. So it's a skill that is very useful to learn, to understand how tidyverse works. And so ggplot is one of the core packages to that. So it's definitely a priority to learn when you get into R. And so by having this kind of very structured methodology and this consistent syntax and vocabulary that you use in ggplot, it allows you to the idea is that you can focus on making a visualization actually look good, and you can focus on the actual science as opposed to spending ages playing around with code. So it gives you more flexibility to use more plotting systems. there is this thing called themes that will show at the end, which allows you to have a consistent theme. So this will set the settings such as like what fonts you're using, what colors you're using, what size everything is. And you can save that entire theme set and then use it again and again, or use one that is a curated one that's available to you. It has a very large developer base, so a lot of people are using it and a lot of people developing it. So this means it's very easy when you're troubleshooting to find help, because a lot of people are spending time every day using ggplot. And there are many libraries available that don't just do the basic things, but will take ggplot and do an extra special thing for you. So this looks complicated, but this is how it built a plot. And this is what we consider to be the grammar of graphics. Okay, so at the heart of it, you'll have your data, right? And your data could have many different observations. You could be looking at height, you could be looking at weight, you could be looking at BMI, like all of these are examples. And so what the plot has is these aesthetics, okay? And so these are what we call an aesthetic is something about the plot that can be changed by the data, or something that could be an output of the data. And so this could be obviously your X and Y axes, but it could also be what shape to use for your data point, or it could be what size that data point should be, the color, the transparency. There's lots of options, okay? And so what happens is you have these aesthetic mappings that say they map what's going on with your data onto the aesthetics. So in this case, the height is going to be portrayed on the y-axis, while the weight is going to be on the x-axis. The BMI is going to be related to color, I think. These arrows overlap quite a lot. So actually the BMI is related to size. These arrows aren't true. Okay, anyway, if you look down at the plot, the BMI is related to size. So the BMI arrow should be going to size. The sex should be going to color. And the shape is related to pet. Okay, and so this aesthetics mapping is the key first step in when you're building a ggplot. And it's really saying what does the data correspond to? Okay, and that's building up this data dependent idea. Okay, so these things are dependent on the data. From this aesthetic mappings, you can control how the aesthetics are actually portrayed in your plot by controlling things such as scales. So that's the dynamic range of something like BMI. Or if you want to do a statistical transformation, or the geom. And so the geom is what kind of plot you'd make. And then you have the data independent things that you can attach to it. And so this is like themes and plot annotations. And so all of these things interact with each other and can be dynamically updated as you build your plot. And so this is an example, an overview of what the example code would look like for a scatter plot. And it seems super complicated. There's lots of lines and lots of data arguments. But in reality, you don't need to use all of those. There's lots of defaults built in, and it's very smart. Okay. And so really, the only thing that you're required to specify, okay, it's much simpler than this. The only thing you require to specify is what data corresponds to what aesthetic. So that's your aesthetic mappings. And then what geom product you want to do. Okay. And so this is actually much more of a typical piece of code that would generate a plot. And you can see this plot is very complicated. There's a lot of different axes of interpretation. So we're considering 4 or 5 different variables here. And we can encode that within just a couple lines of code. Okay, and so we'll go into details about here. We have, this is the data input, this is the aesthetic mapping, and this is the geom. Okay, so it's data, aesthetic mapping, geom. Okay, so we're going to walk you through the data object, what it looks like, and kind of step by step. And then, yeah, okay. So Nathaniel had the question, so does the geom create it? Yeah, the geom is the final step. Without a geom, it won't know what to build. So you can see here, we decided we wanted to show points. So it's will then draw the points. If you don't do that, it might draw the outline of the plot, but it won't have any data inside it because it won't know how you want to graph it. So you need all of these three steps are the 3 steps you need: data, aesthetics, and a geom. Okay. And so the question from Greg is, what is the plus? Okay, so I'm going to get into more details in this later, but essentially ggplot uses a special kind of linker to link together the different arguments, the different functions even in the ggplot. And so it has a plus, which just means that this is attached to this. And you can have lots of pluses, and it can get long as you make it more and more complex. But I'll show you in action later as we build it. Okay. So what we're first going to do is we're going to grab this data set, and we're going to load in ggplot. Okay, so it's actually, we call it ggplot, but it's ggplot2. There was a ggplot, but it got updated. And so if you load it in, and then you load in your data, you can see what we have is we have a data frame. We can use dimension. It has 100 rows, 17 columns. And we can have a look at the first couple rows, see what it looks like. So this is some trial data, and you can see that we have lots of metadata information. It's a clinical study. We've got people's names, we've got their height, their weight, when they were born, where they lived, all kinds of things. So this is lots of different information which we can plot. And so as a default, when we read it in, it reads it as a data frame, which we learned yesterday. Data frames are essential for ggplot. It doesn't like other data forms. It wants a data frame as its input. So you may, if you have a matrix, if you have a matrix, then you might have to coerce it to a data frame potentially. So someone says they can't locate the data patient data clean.txt in the course material. It should be in the folder data, which is in our course. If you remember, you've got to navigate into our course first. Let me just double check to make sure it should be there. Okay, so for Lisa, if we do pwd, oh, not pwd, sorry, I'm getting confused with command line.
Hi, sorry about that, Matthew. No, I just don't see that file in my list of data files.
Okay, so you have the other ones?
I do. I have like the gene expression and I am example, all those.
Oh, that's interesting. Okay. Is anyone else having this issue?
I can send you like a shot of the folder, I mean, the files that I have.
Okay. Yeah. So one good question that we got from Adam is, are you setting the plotting stuff for today? Or are you setting yesterday's intro to R?
Maybe it's yesterday's stuff. Was there another download for today?
Yes, there
okay.
is.
Sorry, I'll take care of it.
No problem at all. No problem at all. So if I can just show you real quick, we go back to this. We are on 11. So if you go back, so today's plotting in R in here. So you go to plotting in R, and there's a download for today's session here. Okay. And then from that, you'll be able to navigate into R course and then data once you've unzipped it. Okay, so yeah, it seems that several people had this issue. So every time, oh, not 111. Every time we do a new section, there will be a different download pretty much. So intro to R was one section, and then there is plotting today. And at the end of this session, I'll show you which ones you should download for tomorrow. Okay. Oh. So once you've got started, you've read in the data, and you can see there's lots of different data types. Some of it is characters, some of it is numeric. And what you can do is, to get a real picture of it, you can use summary, which we've used in the past, and that will summarize each column based on its type. So we have some logical down here. A lot of this is, so we have some numeric. You have some characters, and that will tell you a little bit about the data. So, as we talked about, the thing you need to have is you need the data, which we just have. Then we'll need to create some aesthetic mappings. So that's mapping the data to which properties of the graph we want it to, the data to influence. And then we need to decide on the type of graph we want to use. So we can build this up in a very stepwise manner. You don't have to specify it all in one go. So we can first say ggplot, and we can say use the ggplot function, and we can say our data is patients clean, which is the data set we just loaded in. And if you see, we can look at the class of this plot variable that we just created, and it's a ggplot. Okay. And within PCplot, there is a slot in it called data. So this is a complex object we just created. This ggplot is a complex object, and it has multiple things, multiple slots. So it's almost like a list. Okay, and so one of these slots is called the data slot. And this is where we just essentially saved our data into the ggplot object. And so we can access the data from the ggplot object. Okay, so you can see that this isn't the original object the original variable we read in. This has been assigned using the ggplot function. But the next step is the mappings, right? And so if we look into the mapping slot, it has nothing there. Okay, the aesthetic mapping is empty. We can also look at the theme slot or the layers slot. They're all empty. So we haven't yet specified these things with our function. So we can do this again using the plus in a very stepwise manner. So first you can specify your data, and then you can do a plus, and then we can specify our aesthetics with the aesthetics function. So we're going to say we want our x axis to be height, and we want our y axis to be weight. Okay. And so using the plus means that this gets added to this original ggplot object. Okay, so the plus works only with ggplot objects, and it basically means you can have these functions stuck together and they'll modify the original ggplot object. So if we now save this as PCplot, this will update the aesthetic mappings, and now it knows that x is height and y is weight. We have a question. Can you do AES iteratively? Well, let's check. I think you can, but I haven't done that in a while, so I'm going to quickly check. So I'm going to quickly load in the data. And then we'll save this. Oh, I need ggplot. Okay, so let's do that. Yeah, so you can add it step by step, but if I was to say I want both to be height, it will overwrite it. Okay, but you can see so far within the PCplot object we've made, only the things that we've specified are included. So there's no theme or layers yet. And so the last thing we can do is we can add plus geom point, and that's going to produce a plot. Okay, but actually, okay, I got one step ahead of myself. So that produces the plot, but the plot is saved here. So it doesn't actually produce anything to your screen yet. So this is a ggplot object, but it doesn't create the plot until, or it doesn't display the plot because it's being saved here. Okay, but these are the 3 steps that you have to make a ggplot. And so you can look at the properties now, and you can look at the layers, and it has a geom point saved here. Okay. And then to actually just display it, all you need to do is type in the variable. So you just type in PCplot, and because you have all the 3 steps saved, it will produce the plot in your display. Okay. Does that make sense to everyone? It's a very stepwise method. And it's yeah, I think it's fairly intuitive as you get to know it. Okay, so next we're going to look into geoms. So there are lots of different geoms. I'm going to show you some of them. And these really show you, basically give you an idea of the plotting options. And so typically how people work with this kind of data is they'll define everything up top apart from the geom. And so you can do this all in one function if you want. We did it in step by step, but you can just do it in one go. And so in this stage, I'm saying data equals patients clean, mapping equals AES. and I define this object that has the data and the mapping. This is typically how people work with ggplot. And then they'll try out a bunch of geoms and have a look at what they look like. So I can just do pcplot plus geom point, and it will show me this. Let's see, there's actually an error there. Yeah, so you can see we do exactly the same again, right? This is the same thing, but we change geom to line, and then we get a line plot. Or you can do geom smooth, and it will apply a smoothened lows curve. You can also play around. So there's also a bar plot option, right? And so with a bar plot, the only thing you need is an X value to separate your data into. And so the X we're interested in is sex, and then it's just going to be counts based on the division, how many males versus how many females. And so then with this updated aesthetic, we can then do geom bar. Oh, when trying this plot, I got this error in loads namespace. There's no package name called father. So I'm assuming you're talking about the bar, probably actually this one, I think, if I'm correct. Slide 22. Okay, so this is a first plot. So if this is the case, then try and install father. Sometimes this happens when you install packages. It's supposed to pick up all of the dependencies. Okay, and so there's still an issue with father. Oh, interesting. Okay, so it seems like there's an installation issue. This could be OS dependent, potentially. But it seems that it fixed someone else's problem. And so when installing, it asks you, can you install the source packages? And you should say yes at this point. Yeah, so as long as you have it installed, so Greg has a question or a comment. I don't have father loaded, though I have it downloaded. Okay, so once you download something, if it is a dependency for something else, so say ggplot needs father, then it should load it in for you automatically. Pretty much every package will depend on other packages, and it would take forever to load in every single one and all its dependents. So the way it gets around that is it will load in everything for you. Okay, so for the interest of everyone else, I'm going to ask, I'm going to message JD, who's here, to see if he can help troubleshoot this father issue with I think it's Javier, right? Yeah, so so it's affecting a couple of you, huh? iOS Mojave. So Mojave's a little old, right? So it could be that this package is no longer supported. But I think for now, let me see. Can I just ask, so King is also having an issue. Are you also working on Mojave? As your operating system? Big Sur. Okay, so these are quite old OSs. So it could be that it's an OS issue. Okay. Or not. Right. Don't worry. I'm gonna carry on. Sorry, it's not working for you. If you can, I just messaged my colleague who's in the chat. He's gonna have a look at it and hopefully and see what he can do. I think it's I just sent him the names of the people that are struggling with it. So hopefully he'll be able to help you figure it out. But we're going to plow ahead for now. Okay, and I'll have a look at it at the end as well if we have time. Okay, so we just showed a bar plot, right? We just updated the aesthetic to actually something that's interesting for a bar plot. And then we just do +G on bar. Similarly, we can do it for histogram. So we updated the aesthetic to something that would actually be interesting to plot with a histogram. And then we just do geom_histogram. Okay, and some of these have nice little messages that can be informative, right? So like this one is saying it's using the Loes method. You can alter this if you want. And this one is saying it's using bins equals 30. And so it tells you how to pick a better value for that. We have geom density, box plot, violin. And you can see that we're not doing too much. We're, I guess, changing the aesthetic to something that's maybe more appropriate for this kind of visualization. But all we're doing is adding also what kind of plot we want. And it's just, so it's the same kind of rationale, the same language the entire time. And so those are the main geoms that people use. And so there's 2 pages here that we point out. The ggplot2 guide is very, very good, very extensive. And they have these cheat sheets. And these cheat sheets are really, really useful. And they show a lot of the different options with ggplot. And they have a list of all the geoms. Okay, and then we also have here, this is also another nice list of all the geoms here. And some of the parameters that you'll need for them. Okay, and you can also just go into our graph gallery, right? So we talked about this last time, but you can go here, and this isn't just for base plot. You can look, and it has code for how to do it in ggplot. Okay, aesthetics. So we talked about aesthetics mapping, but the aesthetics themselves can be directly altered as well. So if you remember, aesthetic mapping is what points in the data correspond to what aesthetics. But some of the time, like in this plot, right, we have the height, which is going to be our X aesthetic, weight, which is our Y aesthetic, and maybe we just want some red points. And so there's going to be no mapping for that. That is just a constant we want to add. So what we can do is actually alter the aesthetic mapping, but instead of doing it up here, we can alter the aesthetic. And yeah, instead of doing it up here where we're doing mappings, we do it actually in the geom argument. And so this means when we do it in the geom argument, we're going to update it. And so in this case, we're just going to say color equals red. And so with this kind of these mappings, it means that the aesthetics can be dynamically updated depending on how we set the settings in the plot. And so we can keep supplying additional information to AES to further refine what is being shown, how it's represented, and such. So, like first we'll look at this plot. This is what we did earlier. It's a very simple plot, but we can add further aesthetics, and this will start to parse the data. So in this case, we're going to be interested in color as an aesthetic, and we're actually going to be interested in adding it as an aesthetic mapping for sex. And so by just simply adding this this aesthetic mapping right here, now everything related to color, like the sex, is split by color, and it also adds a legend automatically. So this is really nice. And you can see how convenient this is. Actually, yeah, something in parentheses up here. This Hadley Wickham is Australian, so he spells color like me with a U, but he makes it for everyone, so it will accept both forms of color. And it's the same with everything in all of the tidyverse packages. They'll accept both American and English ways of spelling things. Okay, and so the only difference between here and here is we've changed the aesthetic mapping to be shape. And now the difference between female and male is related to the shape.
Can both of them be related to sex? Both color and shape?
Yep, indeed. I don't know if we do that right here. No. So you can stack all these things as much as you want. So I could, I have it loaded in, so I can just show you real quick. Let's switch you over to here. I can do other ones as well. So you can see how here I've done a lot. So we've got color, size, shape. I could also do, I'm going to introduce more of these later, but there's also alpha. So that sets the transparency. So you can, like, this is not useful at this point, but there's definitely a way to do this in a very useful way where you set lots and lots of different things to be very different between your different data types. And you can also, like I did that all on sex, but we saw a plot at the beginning where we separated based on sex, based on, I think, whether they smoked and what pet they have. And so you can separate based on all of these things all at once. Although whether that's completely advisable, and because the plot becomes quite difficult to understand, is that's a different thing. Okay, what about choosing the actual colors or shapes? Yeah, so I'll show you how to do that with scale in a little bit. And we'll get to that. Yeah, because the defaults are not, like the red and pink is fine, but it's not the most aesthetically pleasing. Okay, so We are here, so we did point shape. So yeah, you can update the mappings like we did, and it will automatically like pass your data into these groups. Or you can update the aesthetics directly by putting it in the geom itself. So that's when we added red. So you got a taste of how to do this here if you want to directly specify things. Okay, and this will just mean everything will be one color, and that is red. Okay. And so this is actually showing something similar to what I guess I just demoed in the RStudio. You can just keep changing the variables and it will alter them, and you can just keep being additive with this as you go. Some plots have specific parameters that they'll use. So instead of using color, a box plot or a violin plot uses fill, because I think color actually corresponds to the outline. So color does stand for something, I think, but it stands for the outline, which is less useful. Most of the time you want to actually change the fill. And so again, for like a really good list of all these different geoms, and also some of the parameters, you can just look at the cheat sheet and the quick reference guide that I showed you before. And you can also use the question mark with these functions as well. And there's lots of information about if there's any nuances with that specific geom type. Okay. So next thing we'll talk about is facets. So this is a ggplot specific feature that actually the website with all the graph examples is called our graph gallery. It's linked to in the previous one, and I think at the end of the previous presentation, and also I think at the end of this presentation as well. But it's called our graph gallery. They do have a sister site for Python graphs as well, for those that are Python fans. Yeah, so one nice thing about ggplots that is specific to ggplot is not only can you, like in this example, right, we're splitting it up in a single plot. We have lots of different variables we're looking at once. A nicer way to do that maybe is to actually split into separate charts or separate plots based on one of the variables. And so we can use functions facet wrap or facet grid to get an understanding of that. So I'll show you that in action. So here what we're doing is we use the function facet grid. And what you tell facet grid is what variable you want the rows to be and what variable you want the columns to be. So in this case, we're just doing a regular ggplot, the same as we did before, height, weight, but color by sex. Okay, we save that. And if we just did this, it would look like this, right? But then we want to break the grid up into groups based on smoking and sex. Okay, so this means in the columns we'll have the sex, so we have female and male, and then in the smokes we have non-smoker versus smoker. And so you can see, well, it's hard to exactly say for sure, but there seems to be a slight trend for maybe slightly higher weight in non-smokers. But who knows? It's not very much data. But passing the data into these nice quadrants can really help start to dissect what you're seeing. And you can see how simple it is, right? We've just done this code to make the plot, and then we just add an extra facet. If you want to just split by one factor, you can still use facet grid, but you just use a tilde to as a placeholder for which side you're in. So if you want to say have columns, you do the tilde first. And so you can do this with sex. And so you do tilde, then sex, and it splits female, male in a column specific way. Then if you do the tilde afterwards, and this time you also actually need to add a full stop to make it work, it will divide it by row. Okay. So I think that with faceting, you can quickly go from quite a simple plot to something that's quite complicated and quite nuanced that actually makes it much easier to understand what's going on with your data. And so we've been talking about facet grid. Facet wrap does similar things. It's less, it's less grid based. And so if you have one variable, it's quite good at dealing with that. So in this case, we're just doing facet wrap, and we do by smokes. But we can also do much more complicated ones where we want to do lots of things. So here we do facet wrap, and we want to break it up, but we want to break it up by pet, smokes, and sex. Okay, so in this case, we're looking at bird owners that are non-smokers and female, then bird owners that are non-smoker and male, etc., etc. And so this in this PowerPoint, like this presentation, it looks atrocious because you can't see any of the data. But if you were able to actually export this properly into a like a real PDF document or something, that would stretch out the y-axis, and you'd be able to see all this data, and you'd be able to compare the trends between them in quite an easy way. And here, yeah, we have a similar situation here where we're saying we want to split by smokes on the row way and sex and pet on the column. Okay, so faceting really can help it's a nice way of trying to aid your interpretation of what's happening with your data. Okay, so something that we learned yesterday was about how ordering works, and specifically we're talking about factors. A commonly asked question is really, how do you alter the order of things within your plot? Especially when we look at things like box plots or bar plots, things like that. And so here we have an example. We're comparing female to male, and we're just looking at weights. And the same rules that we learned yesterday apply. So it goes by alphabetical order unless you specify. Okay. And so it considers everything for this kind of data to be, unless it's specified as a categorical data, it just inherits this idea that it's done by alphabetical. But you can add in levels to make it ordered in the way you want it to be. So if you look at the variable for sex and you ask it what the levels are, there is no levels associated with it at the moment because it's not a factor. But what you can do is you can make it a factor, and you can specify the level order you want. So we could say male first, and we can apply the factors to specifically the sex column. We can do this whole function, and then we assign it back. Okay, so this is a very common operation, which I think we've seen before, where we take a column, we do something to it, we coerce it in some way, and then we assign it back to the same place. And so in this step, we've modified it to be a factor, and we've modified the levels. And so now, instead of it being like female versus male, it's now male versus female. This is a really common issue because of if you're going alphabetical, common way that you want to plot something if you have a wild type is you want the wild type to be first, and then you want the mutant to be second or third or fourth. If it's doing it alphabetically, the wild type is always going to be pretty much the last one because it starts with a W. So this is a really common issue that we face in science and with data visualization, and it's a very easy fix. Okay, the question I got from Nathaniel, was it already a factor just with default levels? It was not, because we read it in with all this time ago. Oh, it was quite a while. Maybe I didn't need to do this. We read it in with read.dlim. Okay, and if you remember, we talked about it yesterday, the reading in using the base packages nowadays defaults to reading it in as a character. If you're using older versions of R, it will read it in as a factor by default. But because that's been updated, it's not like that anymore. Oh. Cool. So what we're going to do now quickly is we'll just have a quick 3 or 4 minute break, and I'm going to give you a poll during this time. And I'm going to grab myself some water. And I'm going to have a quick Google search about father. Okay, I'm going to let this poll run for another 30 seconds while I'm just doing some reading about father. And we'll have a little breather before we get back into ggplot2. Okay, let's end the poll. I'll share the results. Okay. For the people that had issues with father, I don't know if Jujil Dong was able to help you at all. I know he was lurking in the background for some of this. My 2-minute search seemed to suggest that maybe reinstalling the scales package might help, because that's the one actually installing father. And it might just be to do with some versioning issues. So I just typed that into chat so you can get the right one. Hopefully that helps. And if it doesn't, you just let me know at the end. Okay, so we're going to jump into these poll results first, though. And so Aes Mappings control which parts of the plot are controlled by your data frame. That is true. I don't know if I phrased that in the best way, but yes, the mappings are well, tell the ggplot what parts of your data are going to control which properties of the plot that you're making, such as X or Y or color. Geoms control the plot type. Yes. So we saw how the geoms, we can specify lots of different geoms to create lots of different plot types. Plot order is governed by order in the data frame. That is not true. So we just talked about that. The plot order is determined by the alphabet. Okay, and then that can be overruled if you have a factor. So, for example, our example with males and females, the plot order is governed by the alphabet, so females will appear before males. But we went in and we changed the levels, and then we made males first. And then similar facets control which part of the plot are controlled by your data frame. So this is an echo of the first question. And we know that's not true. Facets are the way of splitting up your plots into many plots based on a single variable or multiple variables. So things that look like this. So this is the faceting. Okay. I just got a message from my colleague. He has to dash. For King, and I think it was Javier. Did you have success with father in the end? Give me a shout if not. Okay. So we're going to now get started with the last part of today's session, and we're going to be talking about scales, amongst other things. We're going to be talking about how to save your ggplot, and we're going to get into, I forget who had the question, but how to actually alter which colors that you use on your scales, and how you alter which shapes that you use for your images. Okay, so cool. That sounds like good news, King. Fingers crossed that fixes it. Okay, so scales. So all the scales that we've been looking at and the legends have just been handled by ggplot2. We've just been using their defaults. We have that kind of reddish pink and the light blue. We've been using circles and triangles, and that's kind of all the defaults. To have finer control over this, we use a collection of methods called scales. And they're divided into different combinations. You have scales that they have two attributes to them. You have the scale function. The first part, or the first attribute, is what aesthetic they control. So it'll be scale point. Say if you want to change the point size, or scale color. And then the next part will be the type of data, and whether this is basically continuous or discrete data. And so every scale function will look kind of like this. You'll have the scale underscore aesthetic underscore type. And so if we were to like, I can show you in R real quick. If you do a type in scale, can you see my autocomplete pop up? I might have to, okay, you can, cool. So you can see, we can start to see this. So for alpha, which is the transparency of your dots, you can start to see this is the aesthetic. And then we have all these different kinds of data types that we can update. But there's many beyond alpha. So we have color, and we have fill, all of these different aesthetics we can update with scale. And so this gets at this idea of consistent language use, consistent syntax. Anytime you want to change these scales, whether it's X or whether it's shape or anything like that, it's going to be a very similar function. Okay, so common things that you're going to be putting into scale, right? Okay, so as you saw, there's a lot of different scale functions. All of them do a lot of different things. And depending on the data types, the arguments that go into them can vary a little bit. But there are some common arguments that you're going to be putting into scale. Some of these are like, we have name. So that is going to control when you have your if it's on the axis or whether it's on the in a legend, it's going to control what that is called. Okay, so if, for example, in this right here, we have here, I could change the scale so that I can update the fact that when I split by sex based on color, it's not called sex anymore. We can call it gender or something. We can also update the limits. So if you have a gradient of, if you have, say, a continuous data set and you want it to go from use alpha to set the transparency, you might not want to start the bottom set of your data to be completely transparent. You might want it to be like 50% transparent. So you can set that bottom limit to be higher. Or you could do it with color, or you could do it with shape, right? You basically set the limits of how much the variation can be. Breaks shows you if you have any labels or any tick positions, any breakpoints in your data. On the axis, so this is pretty much for the only the axis scale. You can control where they appear, and then the label names at each break. So you can change something. Say you have like sex again. You have male and female. If you wanted to update those to something else, you could. And so, as we mentioned before, there's different data types. The most common, different ones that you'll be using are continuous and discrete. And so these are especially important if you're working with the X and the Y scale. And so these are the ones that you use to control the X and the Y axis. So you can use scale X or Y, continuous or discrete. Okay, so there's been a lot of me talking, but I really need to just show you some examples for this to make sense. So here we go. This is scale X continuous. Okay, so what we have going into this is we have our PC plot. We've decided we want a geom point, and we're doing a facet grid. So this means we're splitting it up into smokes versus sex. Okay. And so we're specifically updating the X axis. Okay, so this is our X axis down here. And this was a continuous data set for centimeters, right? It just, before it showed something very similar to weight, but it showed the numbers in centimeters. Here, we're actually going to break it down into groups, and we're going to say we want to change the name to be height in centimeters. Okay, so we've updated the name. We want to create some limits. So this is actually going to limit our data set. And so anything above 200 and anything below 100 is going to be removed from the data. Okay, so maybe we can go back. We have this data not too far away. It's here. And so it's going to change the way the data looks, right? Because this is around 200, but our bottom is 160. And so we're now going to redefine this, and it's going to squish all this data points up, because we're going to say our bottom limit is 100. So you can see it's all squished up. Then we're going to add some breaks. And so these are going to be where our ticks are for the axis. And so we want 125, 150, 175. And then we're going to add some labels. So we have small, just right, and tall. Okay, this is kind of a silly example, like it's not super useful, but you can imagine using this for all kinds of other things. If you ever want to categorize data. Okay, so that's an idea of how these scales work, okay? And we're implementing it currently with the x-axis, but it works with any other aesthetic in pretty much the same way. Okay, so here we're going to, again, be scaling, but we're going to be using, again, the x-axis, but it's going to be a discrete variable, okay? And so we're going to update it to be women and men instead of female and male. Okay, so it's the same data inputs. We're doing a geom violin. And then we add the scale where we're specifically just altering a few things. Okay. Yeah. The relabeling has gone badly here because generally women are not twice the height, or not twice the height, 20 centimeters higher than men. But you get how we did it though. That's the most important thing. So for the X type build, you just have to know what type of data you're dealing with. Yeah. So you just need to know, am I working with a discrete data set or a continuous data set for this to work? Which I would hope you would know that because you're creating plots of your data. Okay. So it's just, yeah, scale X, continuous, scale X, discrete. And so that's how you control your x-axis or your y-axis, right? And so if you remember when we did base plotting, right? You'd have to remove the axis completely and then replot it in step by step. But here it's a simple extra line and it will modify it. And so here we're doing both, we're doing the same data, but we're doing scale X and scale Y. Okay, and we've also added in an extra complexity because up here, when we defined the ggplot aesthetic mappings, we said the fill is smokes. So it handles that all fine. We're saying we wanted a violin plot. We want our discrete, and we're giving the labels of women and men. Okay, even though these are the wrong way around. I'm going to take a note of that because that's kind of goofy. Okay, and then we can add our y continuous. So we're doing the same as what we did a couple slides ago, but we're doing it on the y-axis now. And we're saying we want the breaks to be 160 and 180 for just two very clean definitions of what short and tall are. And so, as I mentioned before, a lot of these aesthetics, everything's automatically chosen for you. You get this red and this blue. You get circles. You get triangles and circles if you get two of the shapes. The alpha is always set to 1 so that you can see the whole shape. And these are a bunch of defaults that maybe you don't care about. So as before, right, you can control an individual aesthetic. If you want to apply it to the whole plot, just in here, in the geom, right? But you might want to actually use a scale to be able to scale it relative to some of your data. And so here we're making an incredibly ugly plot, but it is our own custom plot. And we're controlling the scale here for color. So here we have scale, color, and we're saying manual. Okay, so we're doing a manual choosing of what the colors are, and we're saying green or purple. And we want the name, which is now going to be up here, to be gender. So this can be helped with discrete variables. So here we're directly specifying the colors, hence why we're using the manual aspect. But when you have lots of different variables, it's impractical. So that's when you might start wanting to use palettes. Okay, and so we introduced palettes before. There's lots of different palettes. There is a group of functions called the Brewer set from Color Brewer that actually gives you a bunch of other palettes as well. So we introduced Viridis before, and I gave you a link to lots of different custom options that people have made. But if you want a package that just has a bunch in, Color Brewer is really useful. And so Color Brewer is built into ggplot. And so what you can do is here you go scale, Color Brewer, and then you just say what palette you want to use. Okay. And so there's lots of different ones. So we have some that are diverging, some that are very qualitative, and some that are very sequential. Okay. And you can search these to actually look at what they look like. Or you can just put them into your plot and see what it looks like with your plot. Okay, so you can see here we use the set to option, and it gives us a range of colors that corresponds across. Okay, and so like I said, you can look up the color brew options here. I think this actually takes a while to load, but it's a cool website. Yeah, so it's a pretty cool website. I can't remember what the data is, but you can break stuff up with different colors. And then you have some diverging options as well. So you can have a look, figure out which colors you like from Color Brewer, and then they're all available to you automatically in ggplot. Just going to get some more water. Okay. So that's kind of showed you how to alter colors, right? We've shown you how to manually do it or how to use a palette. Okay. There's actually also, for those of you who do, oh no. For those of you who did like Viridis earlier, there is an option to do scale color Viridis. Viridis is also built into ggplot. Yeah, but there's lots of different color options and lots of control. So color Brewer is a nice one. Scale color Viridis is another one to get palettes. And then manual is a way that you can actually directly say that these are the order of the colors I want to use. Okay, so next we'll talk about more continuous scales here. So we've been talking, we've been so far talking about assigning very discrete groups to, or colors to very discrete groups. But we can use some of the other aesthetics with much more continuous variables, so that we have a nice, really qualitative measure of how things change. And so the common ones to use for this are the alpha and the size. So this is alpha, and this is a really nice use of alpha. And so you can see here the alpha is basically controlling the transparency of your dots. And so we have in the aesthetic mappings, we're controlling, saying that the alpha is BMI. Okay, and so we know that BMI is related to height and weight, and so we can directly show that in the plot. And so then we do a geom point, and then we're going to say scale alpha, and it's continuous. Okay, so we have continuous data, so we're going to do it continuously. And then we can control the range. So this is basically, we're saying the limits of what values we should use for alpha at the lowest BMI and what value of alpha we should use for the highest BMI. And obviously with something like alpha, you don't want to go, I think I mentioned this before, you don't want to have the lower limit to be 0 because you just won't see the dot. It will be completely see-through. So a nice low range is 0.5. And you can see that as people generally get heavier with a shorter height, their BMI is much higher. While if they're taller and skinnier, their BMI is lower, right? And so that really is the BMI relationship, and you can see that trend nicely. Oh, if you want to reverse it, I assume so. Most of the time when you want to do limits like this using ranges, you can just normally start with the higher number and go to the lower number, but let's give it a go. So that's the original plot. And let's go for 1 to 0.5. Yep, and that just reverses it. So it's nice and flexible. Yeah, so we got that. You can also do similar things with size. So here we're doing scale size continuous. It's exactly the same kind of data. And you can do range equals 3 to 6. Okay. So we touched on limits earlier. So range is really nice because it shows you what range of, say, in this case, we're looking at size. What range in sizes am I going to use to display this? Okay, so the bottom of my sizes I'm going to use is a size 3 dot. And the top size is a size 6 dot. The limits, on the other hand, limits what data comes in. Okay, so the two sides of the same coin almost. They are limiting deciding essentially what is the bottom and what is the top in your display, but one is coming from the data angle and one is coming from the actual aesthetic display angle. Okay, and so the thing with limits is anything that is outside of these limits is removed from your plot, which is always, that's a scary thing to do, right? Maybe you want to focus in on a subgroup, and so you are limiting what data you're looking at. But generally, it's not good practice to be purposely obscuring data. So if it's helping clarify something, but you're being very transparent and saying, I'm obscuring this data because I want to just focus on this, that's cool. But if you're just hiding like outlier data points, then that's less good. But this is how you would do it, okay, with the limits. Yeah, and so then you can add in the argument for labels. And what labels will do is it will just modify what labels are used in the legend. Okay. So before, if we didn't have labels, it would just say 25 and 30, right? But now what we're saying is we want to label 25 as good and 30 as good, but not 25. Okay. And the key part of having labels is you need to have a control of the breaks that you want to label. So here we're saying the breaks are 25 and 30. Okay, and for something like this that's continuous, what the breaks are really doing is just controlling what you're displaying in the legend. And so for continuous stuff, we can also, as no surprise, use color again. Okay, so we're revisiting color. And so some of the options we talked about earlier were like, if you have this nice categorical data and you want to say male versus female, these are the colors, or which pet they have, you can visit those colors. But obviously color is a gradient, and you do have these spectrums that you can use to then illustrate some of the data that we've already been looking at. And so two of the functions that are useful for this are, we have scale color gradient, which gives you a 2-color gradient, or scale color fill gradient 2, which gives you a diverging color scale with a midpoint color. Okay, I hope that makes sense. So like this one would go from like, I don't know, white to red or red to yellow, but this one would go from like a red to a yellow to a black or something like that. And so we can use that in much the same way as we've been using for these other scales that are continuous. We say that we want the color aesthetic mapping to be BMI. And then we add in a scale function, and we want it to go from low of white to high of red. Or we do scale color gradient 2, and now we define a low, mid, and a high. Okay, and we can also control what we think the midpoint should be. So in this point, we're taking a median from this. And so often it's more important where the midpoint is for this kind of data, because that's the middle of your color, 2-color gradient. And so defining the high and the low might be less important for this. And you can add extra things, like just as we did before, you can add breaks, labels, names. All of these things can be added into any of these scales. So here we're adding the BMI, but we're just saying high versus low instead of actually informative numbers. And they can still be combined with everything else, right? So we can still do male versus female splitting, like up here, by having the shape equals sex. But we've also got this nice gradient on the BMI. And so this actually works a lot nicer than some of the other aesthetics we looked at, because it does have this essentially 3-color diverging pattern. So you can see what the median is and what it's supposed to be, essentially in the trend in the middle, much easier. And then pick out what are the outliers on the outside. Okay, so that's scales. Okay, and so I don't think we covered every single part of what you can do with scales, or every single aesthetic that you can alter, like the symbols and stuff like that. But it's all the same rules, essentially. You just use the scale, you use the appropriate aesthetic, and then you decide on whether you want to, how you want to update it, what kind of data it is. And then if you have any problems, you'll be able to find the function. You should be able to find the function that you need to do. And if you have any problems, you can just do question mark on that function. Okay, so there's a few statistical transformations that you can do in ggplot pretty well, and that are very efficient. Okay, so yeah, like a lot of the statistics is just done automatically. So like when you do a histogram, technically you're doing a lot behind the scenes to actually decide on your bins and things like that. ggplot takes care of that. So does base as well. But the nice thing about ggplot is it adds in this extra level of statistics that you can put on top of it. And it does it in a very, again, it's in a consistent method. It fits with how we've done everything else with ggplot. And so it makes a lot of sense. And so this uses a stat smooth, which we've kind of touched on already, and stat summary. So stat smooth we kind of used a little bit earlier, but it's a way to make a nice smooth fitted line. And so here you can see we've created this ggplot. We've decided we want points, and so that's what's put all the dots out. But then we've also added stat smooth, and that's adding a nice lowers model on top of it. Okay, you can add different methodologies into here. So in this case, we're going to add method equals lm. And instead, it's going to fit a linear model. Okay. I'm not sure which is most appropriate, but that's a different question. Assessing statistical models is a whole different kind of thing. Yeah, but it's very easy to control these. There's lots of different methodologies and lots of different things you can do with ggplot to fit statistics to them. The other nice thing you can do is actually, if you're splitting up the data, like we are here, male and female, it will actually perform the statistics separately on the groups. So in this case, we're adding in the aesthetic for color equals sex, right? And so that means when we do the linear models, it's doing them, and it color codes them as well, which is cool. And this could be important, right? Because a lot of this, if we actually looked at the data, right, this model, the lowest model, has this weird kink in it, and it seems to be different, basically different kind of patterns, because we have males and females, and they have very different height versus weight relationships. And so we can actually get further to the bottom of that. What we might want to do, though, is sometimes you do not want to, if you want the group information to be present, but you still want the statistics to be over everything. Does that make sense? So in this case, we're splitting the statistics up over 2 groups. Sometimes we want the 2 groups visualized, but we actually want the statistics to be over everything. So in stat smooth, we can redefine the aesthetics that StatSmooth is looking at. So StatSmooth, the aesthetics that it's looking at is just weight and height. We don't add in the color. And we also use the argument inherit aesthetics equals false. So that means it's not reading the aesthetics from the ggplot object anymore, and it's only reading them from the ones we give it. And so that means we can get this nice coloring between our two groups, but we can also get a general trend over the entire population. Okay, so that's StatSmooth. There's then StatSummary. And so what StatSummary does is it allows you to provide, it's almost like apply. It will do a statistical function, and it will do it over your data set. So in this case, we can use the statistical function quantile. So this will divide your data set into groups, quantiles. And so, but this could be any kind of compatible statistic. Okay, and you can always do question mark stat summary to see what is compatible. But we just do our usual, we've got our PC plot. We add stat summary. We're using a function of quantile. We add what geom we want the output to be from stat summary and any other attributes we want of it. So we're going to say we want a big purple dot to represent the quantiles. And then it just adds in the quantile data on top of our jitter plot, which we're making. So this is a really nice tool that just adds some complexity and depth to your the plots you're making. Okay, so hopefully at this point you can see how with ggplot you can make some very complex and statistically rigorous and interesting plots very, very quickly and in a straightforward manner. And hopefully some of this language has started to make sense to you. It will take a little while. I think base plot to begin with is easier because it's more straightforward and it's very much, you put something simple in, you get something simple out. But as you get further into your data analysis, you'll find you'll be able to do much more with ggplot. So that's why it's important to learn both. Once you get to a point where you're making a plot that you're really happy with, you can start to play around with something like themes. And these are really useful if, especially when you have a project you're working on for a period of time, or if you are rating a paper, you want all your plots to have a similar look to them. And so the themes, they don't rely on anything to do with the data, and they really control anything that isn't data. So it could be things like titles and their size, or the background color, what fonts to use, things like that. And so a lot of themes are used by default, or a lot of themes are included in ggplot, and the one that's used by default is called theme_gray. Most people hate this theme. And the reason for it is a lot of people don't like the red and blue, and a lot of people do not like this background gray. Okay, and so it's really easy to just update what the theme will look like once you found the theme that you like. And so a common one that people will use is minimal. So you can see here, this is a default plot. We haven't done anything special with it. We just have data, mapping, and then geom point. Okay. If we take that PC plot and just do PC plot plus theme minimal, it will then change the way it looks. And so we get rid of most of that gray box, although we do have some cross checks. Okay. So there's a bunch of different ones, and there are separate packages that have even more in them and have collections. So we can go to GG themes. And you can see there's tons. Okay, and you'll find that people, again, similar to palettes, people will make them for their different fandoms and stuff like that. So I saw one recently that's all Star Trek themed. So if you want to make Star Trek themed plots, you can. But there's a lot of like very nice ones that will make very professional looking plots as well. Okay, so oh no, sorry, Adobe is trying to update. No. Okay, there we go. What you might find though is the themes that you're looking at don't quite do the job that you want. Maybe you have a theme, you found a theme and you like everything apart from one thing. Like for me, I quite like this theme. I don't like the fact that it doesn't have the axis line. So what you can do is you can take the theme and update it or create an entirely new one. And so it's really easy to do that using the theme function. And it's similar to what we've been doing basically with this ggplot object. You can also create a theme object and you just add extra attributes to it, which will govern how it works. So there's 4 main graphic elements that you can control. And this is rect, line, text, and title. And some other related elements, axis, legend, strip, panel, and plot. Okay, and we'll explain what these are. And so using these element functions, you can control and specify what parts of the specify what's used in a theme. Okay, so if you go to this vignette, it has some details about controlling and using themes here at the top. Okay, so to customize your theme, what you need to do is you just open up the theme function and then you put in the bit that you want to customize. And so here, what we want to do is we want to change something called the text element. So that is going to count as any of the like titles. And we're going to say we want that to be red in color. And so now we have a theme, which we could in theory save this for future use. But the only thing we've really done is we've updated the existing theme with the titles being red. You can also do things like change where the axis title is. So here we're saying the axis.title.y. So this is the y-axis title, and we're changing the angle of it. So now it gets rotated around and it's put up here. And so we can do a lot of things like everything. There's a ton of customization options. So this is just a quick example of us doing a bunch of different things. So we're changing the text. We're doing that y-axis thing. We're removing the axis line. And we are changing the plot panels to be white. And the strips of color behind the titles are changing their color to cyan. And so we can create something that looks like this. Again, it's a very ugly plot. We're very talented at making ugly plots. But hopefully it demonstrates that there's you can customize pretty much any part of these ggplots. And if you invest a little bit of time at the beginning to decide what kind of theme that you like and how you like your plots to look, you can save this and just reuse this for the rest of your career if you wanted to. Okay, and so one useful example is with the legend. And so typically it's on the right of the plot over here. Quite often people like it in different places. So maybe you want to put it on the left with the theme, legend.position equals left. Or you can put it at the bottom. And because it's on the bottom, maybe you want to change some of the attributes to it, like the element text or the title, size. Yeah. And so these are all options. And so when you're altering themes like this, we've been using the plus operator. And what this does is it overwrites the current theme, but it overwrites it in a very temporary way. When you're doing this, the elements that you're putting in just replace the old elements. Okay, but nothing that you don't specify is removed. And so anything in the old theme that you're not overwriting, it'll just use the old defaults. And so the plus operator then means it's really good for building up themes from existing themes. Say, like I gave that example, you have a theme, you really like it, but you just want to make a slight tweak. Maybe the accent color isn't your favorite color, or maybe, like I said, the axis lines are not included and you want to make sure they're included, that kind of thing. And so here, the only thing we're changing, this is a theme BW. And the only thing we're updating is the element text, and we're saying the color is red, right? Everything else is maintained. It's still the black and white theme, apart from this title text. What you can do is actually replace themes. So, and actually remove the elements that are already existing in a theme. So this operator here will act to actually replace, regardless of whether, they've been specified in the old theme or not. Okay, so we'll show you that in action. So here we're just going to save theme BW to old theme, just so we have it there for reference. And then we're going to create a new theme using the plus sign. Okay. So this is not overriding everything. Or we can use the theme with the plus replace operator. Okay. So if we look inside the original theme, so this is what a theme looks like inside. If you look at, say, the text attribute, you can see this is the black and white theme. It has a black color, and it has several other attributes associated with it. When we modified the text to be red, you can see the black color is changed to red, but everything else has stayed the same, right? So the size is still 11. Yeah, it still has this positioning that hasn't changed. If you use the plus replace, everything else is wiped out apart from the fact that you know it's red. So this is a way you can start afresh, and you can just get rid of it. You can have a theme. You can use the shape and the fact that you have a data type that is a theme, but it will become an empty container with which you can fill up with your custom edits. Yeah, can we store themes for future use in other sessions? Yes, I think I have. Let's see. Okay, I don't think I have it in here. Okay, yes. So whenever you have an object in R, let me show you this. So I have PCplot, right? This is an object. It doesn't contain anything useful. It's got some stuff to do with mapping, right? It's got that, but it's not like a flat object. So what you can do with this is go save PCplot. And then I'm just going to put this onto my desktop. And this is ggplot. And this is called an rdata object. Why are you not saving? I think I need to actually specify that it is the path file, yeah. Okay. So I just saved this. If I look on my desktop, I can do, let's do. If I look at desktop, I now have this object here, ggplot.rdata. And if you ever want to load that in, I could start a new, let's do this. Let's clear my environment. Okay, so my environment has nothing in it now. Now, if I load ggplot, ggplot is back now. Okay, so save and load allow you to save pretty much any object. And so you can basically save it as this, like, yeah, it's your variable and it gets to be preserved forever. And so this is how, like, when I've made themes in the past that I save them, and then I can load them in if I'm making plots. Okay, let's get back to the slides. But yeah, so like I said, it's nice because you can spend a little bit of time, invest in creating a specific look, and then every single figure you make from then on will fit that look. Your work will look super cohesive and professional. And when it comes to making that paper, everything is going to have the same style associated with it. So you don't have to do crazy things like manipulating all the colors and stuff to try and make it work aesthetically. Then if you need to rerun code, say they want you to change the colors, right? You can update your theme, rerun all your code, and it will do it for all the plots that you rerun the code for. So it's a nice way of being able to have a consistent pattern. Okay, so theme git and theme set. So as I talked before, there is a default theme in the background. And so that is considered to be the active theme. And so you can use these to theme git and theme set to set what is the active theme at the moment. So if you're going to be doing lots of plotting, instead of adding your theme option to the back end of every single plot, you can set the theme at the beginning, and then it will use that for the rest of that session. Okay, we're nearly there. So the last couple of things is titles and labels. Obviously, you want to be able to add titles to your data and control the labels. And so in this case, there's very direct ways of controlling. You can control them through, we've shown through scale X, right? You do scale X continuous or scale X discrete, scale X manual, or Y, and you'll be able to control the name that way. But you can also just use labs, okay? And so lab will allow you to change the title of the entire plot. You can also control the y-axis through the y argument. There's also another function called ggtitle and ylab. So all of these three options work to add labels to your data set, and they work in pretty much the same way. They're just different options. Okay, saving plots. So we saw how to save plots with baseplot. You can use the same RStudio trick if you want, but again, it's not the best. But what you can do with ggplot is there is a function called ggsave. And so you just give it your object for ggsave. You tell it what file name you want it to be and any parameters, and it will save it. And it infers what kind of object you want to save from its ending, I think. And so the nice thing about this is you don't have to worry about this whole thing of like opening a file, then writing that file, and then closing that down. You just build an object. Once you're happy with it, you can then decide now I'm gonna save it, okay, and it will export it. So this is much more dynamic and flexible to you, and so you won't have to just keep rerunning things if you don't need to. One thing to note is it will use your current graphics window when saving the plots. So sometimes when I'm coding, I'm really like into the code itself, and I'm like, oh, I'm going to make this really small. I've been looking at my environment a lot, and so then when it comes to plotting, this is this big, and so then when you do ggsave, you're going to create this really weird small plot that's all scrunched up. So if you make that a bit bigger, it should be fine. But you can also just directly control it with the arguments like this. Okay, so I'm going to finish with a poll, but first I linked to a lot of stuff in this because there's a lot of people using ggplot, and so there's a lot of material out there to help you with this. So there's links to a lot of this stuff. There's also some extra bits, like there's a mailing list if you want to get really into it. I'm not sure what this link is. Even more material. There's a Harvard tutorials. Cool. And as always, if you have any issues, comments, stuff like that, you can just go to our GitHub and raise issues. Okay, and we've had some of these before. Some of these are nice. So actually, this one's really cool. So someone who took our course before found a really nice way to find colors they like. So you can use a gradient to find colors, and then you get the hex code here, and then you'll be able to use that color. And then it also, I think, has palettes built in. So maybe you have to unlock